Every hour, over 100,000 airplanes take off around the world, but only one of them is a true ghost of the sky. It has no tail, leaves no trace on radars, and costs more than gold. The creation of the B-2 Spirit cost the United States $60 billion, and over 40,000 specialists from 600 companies worked on each unit. Its assembly took more than a year, with special hangars, laser-like surgical precision, and materials you can't buy in any store. But what this plane hides is still a secret. And if you watch until the end, you'll find out what it was really created for. The design of the B-2 Spirit strategic bomber began in 1979, when the Cold War was reaching its peak. It was then that the United States Department of Defense initiated the Advanced Technology Bomber program, with the goal of creating a new generation aircraft, capable of penetrating the most advanced Soviet air defense systems while remaining invisible to radars, and delivering nuclear or conventional weapons over intercontinental distances. Leading American aerospace corporations participated in the competition: Northrop, Boeing, Lockheed, and Rockwell. After a lengthy stage of development and testing, in October 1971, the Northrop-Boeing consortium was declared the winner. It was their project that received the designation B-2 and the name Spirit. Unlike previous strategic bombers, the B-2 was built on a unique flying wing design, which provided a minimal radar cross-section and significantly better flight characteristics. In the mid-1980s, the B-2's design had to be significantly changed. The mission profile was adapted for low-altitude flights with terrain following, which allowed for even more effective penetration of Soviet air defenses. This led to a 2-year delay in its first flight and an increase in the program's cost by $1 billion. By 1989, about $23 billion had been spent on the B-2's development, and even specialists from the Massachusetts Institute of Technology were involved in the work, assessing the aircraft's effectiveness under conditions of strict secrecy. The first public showing of the B-2 Spirit took place on November 22, 1988 at Plant 42 in Palmdale, California, which is where it was assembled. The first flight of the B-2 took place on July 17, 1989. Initially, the United States Air Force planned to order 132 aircraft, but after the end of the Cold War and the collapse of the USSR, as well as due to the extremely high cost, the series was reduced first to 75 and then to 21 units, including a prototype, 5 pre-production, and 15 production machines. Almost all B-2s received their own names in honor of American states, emphasizing their uniqueness and symbolic significance for the country. Thus, the B-2 Spirit became not only a technological breakthrough, but also a symbol of American military might at the turn of the 20th and 21st centuries. The production of the B-2 Spirit began not with the manufacturing of individual parts, but with the creation of a completely new industrial ecosystem capable of meeting the unique requirements for technology, materials, and assembly precision. The first and most important stage was the organization of the production base and the development of tools that did not exist before. After the design phase was completed, Northrop Grumman, as the prime contractor, invested over $1,200,000 in creating a specialized integrated composite center in Pico Rivera, California. For this, a former Ford auto plant was repurposed, turning it into one of the world's largest composite manufacturing centers. The production of the B-2 required the development of not only new materials, but also special tools, software, testing laboratories, and automated production systems. At this stage, the following were created: unique molds and tooling for forming large composite panels, automated lines for laying carbon fiber, computerized systems for cutting and shaping parts, and autoclaves for heat-treating composites at a temperature of about 350 degrees Fahrenheit and a pressure of 100 psi. The production of the B-2 began with digital modeling. Engineers created three-dimensional CAD models and then directly manufactured production tools from them, bypassing traditional mock-ups. This allowed for achieving unprecedented accuracy. Even microscopic deviations could affect the aircraft's stealth characteristics. In parallel, a complex network of contractors and suppliers was formed. Over 6,000 companies and 40,000 workers from 46 states of the United States were involved in manufacturing components. Boeing was responsible for manufacturing the outer wing sections, Vought aircraft, for numerous composite elements, Hughes, for radar systems, and General Electric, for the engines. Only after the creation of this entire infrastructure did the direct manufacturing of parts, their processing, quality control, and subsequent assembly of the aircraft at the main plant in Palmdale, California, begin. Thus, the production of the B-2 Spirit started with large-scale preparation of the production environment, engineering innovations, and the development of new technologies, which made the creation of this unique aircraft possible. After the large-scale preparation of the production base, the creation of unique tools, and the establishment of material supply chains, the direct manufacturing process of the B-2 Spirit began. Events then unfolded in several key stages, each requiring engineering precision and strict coordination among thousands of specialists and hundreds of contractors. Manufacturing of the main fuselage and wing sections. The manufacturing of the main fuselage and wing sections of the B-2 Spirit began with the production of the world's largest composite aviation parts at that time. The central part with the crew cabin was manufactured by Northrop Grumman, while Boeing made the 65-foot-long outer wing sections and the 50-foot-long aft section. The slightest deviations could affect the B-2's radar cross-section. In total, over 10,000 composite components were manufactured for one aircraft, using the latest automation and quality control technologies of that time. The precision assembly of the B-2 Spirit is a true engineering feat that unfolded in huge hangars, specially created for this project. The assembly of the main sections took place on massive jigs, special platforms that occupied an area comparable to a football field. Here, hundreds of engineers, assemblers, and quality controllers worked simultaneously, each responsible for their narrow stage. Thanks to three-dimensional CAD modeling, all parts fit together perfectly. During assembly, laser measurement systems were used, which allowed for tracking accuracy down to thousandths of an inch. Even microscopic deviations could disrupt the aerodynamics or reduce the effectiveness of the stealth coating. Every joint seam was checked several times, and after connecting the sections, it was manually sealed with special materials to ensure airtightness and invisibility. The scale of the assembly was impressive. Just the central fuselage section required over 1,000 hours of labor, and the total assembly cycle for one aircraft took more than a year. All stages were accompanied by multi-level quality control, from geometry to electromagnetic compatibility. It was thanks to such attention to detail that the B-2 Spirit became a benchmark of precision and technological excellence in world aviation. After assembling the main structure, the integration of systems began. Electronics, hydraulics, fuel tanks, engines, flight control systems, radar complexes, and so on. Many subsystems had to be redesigned and adapted to the unique requirements of the stealth architecture. For example, placing the engines inside the wing to reduce infrared radiation. One of the most complex stages was the application of a multi-layer radar absorbent coating. The process took place in special hangars with a controlled microclimate. Each layer was applied by hand and then checked for defects that could increase radar cross-section. After completing the assembly and integration of all systems, the aircraft underwent multi-level tests, static and dynamic structural tests, checks of all systems operation, flight tests in various modes, and special radar cross-section tests. Any identified deficiencies were eliminated, and individual nodes could be reworked or even manufactured anew. After all tests were completed, the aircraft was officially handed over to the United States Air Force. In parallel, crews were trained, undergoing specialized training on simulators and in real flights. After the production of the B-2 Spirit ended in 2000, these unique aircraft did not become museum exhibits. On the contrary, they remain at the forefront of technological progress thanks to constant improvement. The US Air Force is investing billions of dollars in modernizing each of the existing B-2s to ensure they meet current and future challenges. One of the main areas of modernization is updating the onboard control systems. Outdated analog instruments are gradually being replaced with modern digital interfaces, which increases reliability, convenience for the crew, and allows for the quick integration of new functions. The crew cabin has been equipped with multifunctional displays, and the flight control system has received new software that provides even greater stability and precision in controlling the flying wing. Every year, over 100 million small arms are produced worldwide. But only one rifle has truly become a legend: the AK-47, a symbol of simplicity, reliability, and an incredible history. It can be assembled and disassembled in minutes, even in the harshest conditions. And that's precisely why it earned the nickname, the weapon that never fails. In this video, we'll take a first-time look behind the scenes of its production, from a raw steel blank to the final tests at the shooting range. You will see the hidden processes that are usually not shown, and you will understand why the AK-47 has become the most recognizable rifle on the planet. When I entered the factory, I immediately felt that I had stepped into a place with a huge history. The air smelled of metal and oil everywhere, and the sounds of working machines created an atmosphere of important work. In this video, I want to show you how the AK-47 is made, starting from the raw materials and ending with the final assembly. We will see how a rifle, known worldwide for its reliability and simplicity, is born from ordinary materials. Believe me, you won't want to miss this exclusive look at the production process. On the production floor, I noticed how ancient methods are combined with modern technologies. Here, they strive to preserve traditions, but also make the process as efficient as possible. Next to the forging areas stood modern machines controlled by computers. The craftsmen here don't just work with metal. They put their soul into every detail, turning it into a part of a legendary weapon. It seems that every corner of this factory is steeped in history and the pursuit of perfection. The manufacturing of barrels is one of the most important and complex stages. The barrel is the heart of the rifle, and its accuracy is very important. I saw how large metal blanks are turned into hollow tubes with the help of special machines. But the real magic happens later, when spiral grooves are cut inside the barrel. These grooves help the bullet to spin so it flies more accurately. This is a very complex process, requiring enormous precision. Even a small mistake can ruin everything, so attention to detail here is at the highest level. I saw how the masters perform this work with pride and responsibility. Each barrel undergoes numerous checks to ensure it meets all standards. Engineers use special instruments to measure and check the inner surface of the barrel. It really looks like a scientific investigation, because even the slightest defect can affect the accuracy of a shot. They check the barrels with ultrasound, measure the diameter, and look for cracks. All this is done to make every rifle as reliable as possible. At the factory, they use both old methods and new technologies. For example, the stocks for the rifles are still made by hand from wood. The masters choose the best wood birch or walnut and process it to be strong and durable. They sand the stocks and cover them with special compounds to make them look beautiful and be strong. This shows that traditions and respect for history are very important here. At the same time, for modern models, polymers are used, which make the rifle lighter and more convenient. Injection molding machines produce plastic stocks with high precision, which helps to reduce weight and improve the weapon's characteristics. This combination of old and new makes the AK-47 truly unique. Quality control is a very important part of the work at the factory. Every detail goes through numerous checks. This is not just a visual inspection, but a real process using ultrasonic tests and magnetic particle inspection. All this is necessary to ensure that there are no defects in the parts that could affect the weapon's performance. Every assembled rifle is checked at a special shooting range to ensure it shoots accurately and reliably. I stood behind protective glass and watched as engineers tested each rifle. First, they checked how all the mechanisms worked, and then they conducted a test firing. This is very important, because even a small problem can cause the weapon to fail at a critical moment. If something goes wrong, the rifle is sent back for rework. Engineers also collect data from the tests to understand what can be improved in the production process. One of the engineers told me that all test results are recorded and analyzed. This allows for continuous improvement of the quality and reliability of the weapon. This process never stops. Every employee at the factory tries to do their part as well as possible. I was amazed that they don't just follow instructions here, but constantly strive to improve every detail, making the AK-47 even better. Applying a protective coating is another important stage of production. This helps to make the weapon durable and protected from external influences. At the factory, they use different coatings: traditional bluing, which makes the metal black and matte, and modern coatings that protect against rust. I watched as workers applied these coatings, and it was clear that they do it with great attention to detail. This is another example of how old and new methods are combined here to create the best weapon. The factory also makes magazines for the rifles. Magazines are an important part of any rifle, and they are given a lot of attention here. They make magazines from durable materials to withstand great loads. Each magazine is checked to ensure that it works reliably and will not fail in combat. I saw engineers inserting magazines into the rifle and checking the feeding of cartridges. This is another important stage that shows how they approach quality here. The most impressive stage is the final testing. In a special shooting range, each rifle is checked by firing it. I stood behind bulletproof glass and watched as engineers fired the rifles, testing them for durability and accuracy. Each rifle goes through a series of tests: single shots, automatic fire, and testing in different conditions. If something goes wrong, the rifle is sent for rework. Engineers collect data from these tests to understand how to improve the weapon. This is a continuous process that helps to make the AK-47 so reliable. When I was leaving the factory, I couldn't stop thinking about the complex history of this weapon. On the one hand, it has become a symbol of struggle and revolutions, and on the other hand, it has been used in wars and destruction. Having seen how much labor and skill is invested in each rifle, I realized that this is not just a weapon, but the result of engineering talent and human labor. Every detail is created with great attention, and this makes the AK-47 something more than just a rifle. It is a symbol of history, traditions, and the pursuit of perfection. The AK-47 is not just a weapon, it is a part of history. It was created to be reliable and easy to use. It can be disassembled and assembled in minutes, even in difficult conditions. This makes it popular among military personnel around the world. The simplicity of its design and high reliability are what make the AK-47 so special. Having seen how it is produced, I understood that every detail matters. Every screw, every barrel, and every stock is created with enormous attention to detail.